Today we are starting Chapter 6. Most of what we talk about today I think will be somewhat familiar. Ratios, proportions, and geometric mean. I think ratios and proportions especially are something that you've seen before. Whether it was in Algebra 1, whether it was way back in the day, junior high, middle school, ratios and proportions should feel familiar. First up, we've got a fraction we need to simplify. Did anybody simplify that fraction? Majay, what'd you get? Good, we should have gotten 1x over 3. This is an Algebra 1 type of reduction. So 3 over 9 simplifies to 1/3. If you want to leave the 1 up there, you can. You don't have to. X squared over x. Well, there's a couple ways you can think about it. One way would be the rule of exponents. If you divide the same base, you subtract the exponents. 2 minus 1 is 1. Or you could have written it out. X squared is x times x over x. So one of those x's top and bottom would have canceled, leaving you with x to the first on top. Number 2, we have to solve for x. The first thing we should do is combine like terms. 2x equals negative 14. Last step is to divide by 2. X equals negative 7. Number 3, another solve for x. This time our first step is going to be good. We need all of our x's to be by each other. So the best way to do that is subtract 2x on both sides. That leaves me with what? 2x equals 12. Then I have to divide by 2. X equals 6. Box my answers in. Okay. Last one. A few different ways we could do this. X is already alone, so really all we have to do is simplify this radical. Any thoughts on how to approach it? Ajay, what do you think? Like multiply them together?
Like find the square root.
Oh, good. So, Ari, is that what you were going to say? Okay. We can split up that radical so that we're taking the square root of 36. It's still a multiplication problem. And we're taking the square root of 16. I would agree that this is the easiest way to go about this. You could multiply those numbers together and then try to find the square root, but then you're dealing with a much larger number. But most of you, I think, know the square root of 36 is, and the square root of 16 is, but we still need to multiply those numbers back together. We get x equals 24. Questions, concerns about number 4? All right, a ratio is a comparison of two numbers using division. The ratio A colon B is written A over B, or you could use words to write it A to B. A and B representing those numbers. So there are really 3 different ways you can write ratios. With the colon, like they showed, with a fraction, or with words. Ratios are usually expressed in, if you had to choose out of these 3 ways, which do you think it usually is? A fraction. It's usually in fraction form. Two ratios that have the same simplified form are called equivalent fractions or equivalent ratios. So it doesn't really matter to me how you write them. If the problem starts off with a colon and you switch it to a fraction, that's fine with me. If you want to keep it in the same form the whole time, that's also fine. It's kind of up to you. The least common way to write them is using words, but even that isn't wrong. It's just different. So if we are simplifying these ratios, I prefer to write them as a fraction. 64 meters to 6 meters, because then this is a lot like what you would have done in middle school, Algebra 1, anytime you had to simplify a fraction. What could you divide both the top and the bottom by? 2. If we divide 64 by 2, we get 32. Keep your units of meters. Over 6 divided by 2 is 3. Again, keep your units of meters. And then that's it. It's simplified. We're done. If you would rather rewrite it back in the colon form, you can. That's also acceptable. Either way works for me. Questions, concerns? Okay, next one. 28 yards to 4 yards. Divide them both by what? 4, good. So 28 divided by 4 is 7 yards to 1 yard. Now, this is where it's a little bit different from just regular old fractions. With regular old fractions, if we had a 1 in the denominator, we usually or sometimes wouldn't write it. In this case, with ratios, you have to have 2 numbers. So that means 1 on top, 1 on bottom, or if you're using a colon, 1 in the beginning, 1 in the end. So if you need to make a note of that, I would do so. Must have 2 numbers. Or must have a numerator and a denominator. 2 numbers. Does that make sense? We can't just drop off the ones here. Okay, I know in fractions in Algebra 1, if you had 7 over 1, you would just write it as 7. That's not going to work here. You must have 2 numbers, and you must use your units. If they gave you units, you've got to keep them. Questions before we keep going? Need more time. On we go. To simplify ratios with unlike units, you must multiply by a conversion factor, or sometimes called a scale factor. Conversion, or you might see them called scale factors. We'll probably get more into scale factors later. So these are some common ones. They are not the only ones, but they're common ones that some people forget. So we'll write them down. Most people should know the first one. 1 foot is 12 inches. We'll work down that first column. Some people know this one, some people forget it. 1 mile is
like 12,800 something.
Whoa.
Something like
okay.
that.
5,280 sounds better to me.
12,000.
John, not nice. Okay, 5,280 feet in a mile. How many centimeters in a meter? 100. How many meters in a kilometer? 1,000. How many feet in a yard? 3. How many ounces in a cup? 8. If you bake or cook, you're more likely to know that one. 8 ounces in a cup. How many ounces in a pound? That one's 16. How many quarts in a gallon? 4. Now, there are other ones we might come across, things like months in a year, minutes in an hour, but those are ones that I'm hoping we don't actually have to write down, that you'll remember those ones. We ready to keep going? Then on we'll go. Simplify the ratios using conversions. Now, one note I will make here is that we want to always use the smaller unit or keep the smaller unit. This will help us stay consistent and not run into any weird decimal inside a fraction kind of issues. So what that means, if we're using the smaller one, we're going to cancel out the bigger one. Anybody in here in chemistry? Okay, yeah, most people. This will look familiar because it's kind of along the same idea as when you would do unit conversions in a chemistry class. So what I mean by that is we are going to multiply this by another fraction or another ratio. If I'm wanting to use the smaller unit, what's the smaller unit out of feet and inches? Inches. I want to keep inches, which means I want to get rid of feet. So when I have my next fraction, feet better go where? Top or bottom? Bottom. Feet on bottom, inches on top. Now, in chemistry, both of these units would cancel out. That's where this is a little bit different. We want to keep the smaller one, so we're going to leave the inches. But we have to fill in these numbers. How many inches for how many feet? 12 inches for 1 foot. Questions about how we're setting this up? Okay, similar to chemistry, not exactly the same because we are keeping our smaller unit of inches. Now when we do this, we've got to multiply straight across the top, straight across the bottom. So when we multiply our numerators, what do we get? 72 inches, thank you, over 22 inches. Questions about that part of it? Anybody feel like we're done with this problem, or do we need to do some more work on it? Kobe, what are you thinking? What? Good, divide by 2. We're not done. We've got to do more work. We can simplify this now that the units are the same. We can reduce it. 72 divided by 2 is 36. Again, keep your units. 22 divided by 2 is 11. Keep your units of inches. Final answer, 36 inches to 11 inches. Again, if you want to write it with a colon, that's fine. I usually default to fractions. I'm going to give you a couple minutes to try B and C. Some of you may have already started on them. If you want to try D, that's fine, but D is a little bit different because our units were squared. So if you come up with the solution to how to get around that, that's great, but we'll talk about it in a minute. So go ahead and give at least B and C a try on your own. Use or keep your smaller unit, meaning not all your units will cancel out. Your answer should still have units in it. We'll talk about them in just a moment. All right, on letter B. What units were they using here? Pounds and ounces. Which one is smaller? Ounces. So we want to keep the ounces. So what was our conversion factor? Careful, what went on top? What should have gone on top? 1 pound should go on top. We need the pounds to cancel each other out. So remember, 1 on top, 1 on bottom is how we'll get those to cancel each other out. And in 1 pound we have 16 ounces. Questions about our conversion factor? Okay, multiply across the top. What do we get? 18 ounces. Across the bottom? 48 ounces. This will simplify. What can we divide them both by? You could start with 2. If we divide by 2, what do we get? 9 over 24, but we can keep going. Now we could divide by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. If you had divided by 6 from the beginning, would have gotten to the same place. It does not matter to me how many steps it takes to get to your final answer. If you find the greatest common factor right off the bat, that's fine. If you do it in smaller increments, that's okay, as long as we all get to 3 ounces over 8 ounces. Questions about letter B? All right, on letter C, which unit are we keeping? Feet. Our smaller unit is feet. That's the one we're keeping. So what was our conversion factor? $5,280 feet over 1 mile. Okay, miles are what we were trying to get rid of. That's the big one. We keep the smaller one of feet. Multiplying across the top and bottom is pretty easy since we're just multiplying by 1. So we've got 5,280 feet to 20 feet. If you wanted to simplify this in steps, that's fine. I usually like to just divide by 10 at first when I can. So 528 feet to 2 feet. Now these are both divisible by 2. 528 divided by 2 is 264 feet. Do I need a number in the bottom? Yes, I do. 2 divided by 2 is 1, but I do need it because ratios must have 2 numbers. So we've got to have both the top and the bottom. Bless you. Questions about letter C? All right, letter D. If you were good with your unit conversions in chemistry, this one might not be so tricky for you. If we have feet squared over inches squared and we're trying to get rid of one of those units, we can't just use one conversion factor or use a conversion factor one time. We're going to have to use it twice. Okay, if we've got feet squared and we're trying to get rid of feet and feet, we're going to have to do it twice. So what I mean by that is our first time around, if we take 12 inches over 1 foot, foot and feet squared, that's only going to cancel out the feet with the squared, and this will still have feet on it, which means we have to do it again. 12 inches over another 1 foot. Now, I'll change colors to show it. Now these feet will cancel each other out. Questions about why we had to do it twice? If you only do it once, you're not totally getting rid of your feet squared. You're only halfway getting rid of it. So we got to do it 2 times. I see some unhappy faces. Do we have questions about that? Kind of goes back to the whole idea from the beginning when we had x squared over x. That's not going to get rid of the x completely. That's still going to leave us with an x. We would have to divide it by x again to make it into a 1. Do we have questions on that right now, or we're just going to let it sit? Some of us seem like it's good. Some of us seem like we're not so sure. Okay, we'll keep going for now. Again, we multiply all the way across the top and all the way across the bottom. 3 times 12 times 12. 432. My units, inches times inches, is inches squared, which is what I want. Matches my units on the bottom. 4 times 1 times 1 is just 4. Okay, we can simplify this. What do you want to divide by? You can divide by 4. So on top we would get 108 inches squared. Don't drop your units. And in the denominator, 1 inch squared. Again, you need a number on the top and the bottom, or in the front and the back if you're using a colon. Questions, concerns? Okay, so the big ideas here are make sure your units match. If they don't match, you cannot start simplifying it. Use the smaller unit when you're using a conversion factor. We're trying to keep the small unit. And then, of course, reduce these like a fraction when the units match. Always have 2 numbers. Are we ready to move on from these problems? Better way of asking it. Anybody need more time on these problems? No. Okay. All right. The area of a rectangular garden is 108 square feet. The ratio of the length to the width is 4:3. Find the length and the width of the fence needed to enclose the garden. On a problem like this, a picture or diagram is not necessary, but in my opinion, it helps. We are told a couple things about this. First, the area is equal to 108 feet squared, or square feet. While we're on that topic, it might be helpful to remember how we find the area of a rectangle. How do we find the area of a rectangle? Length times. Ooh, you're thinking of a circle. Length times width, base times height. I'll go ahead and call it length times width since that's how they're calling it in this problem. So that's important to know. They tell us the ratio of the length to the width is 4:3. So, for example, I could label the length with a 4 and the width with a 3. However, I know that my length and width are not really 4 feet and 3 feet because 4 times 3 does not equal what? 108. I know that this is the ratio I have to keep though. For example, what would be in the same ratio is if I were to have a length and a width of 8 feet and anybody know what the other one would be? 6 feet. If I multiplied them both by 2, I would be in the same ratio. 8/6 reduces to 4/3, but is that going to work? No, because 8 times 6, again, does not equal. Doesn't equal 108, so it doesn't work again. We could keep using this guess and check method, or we could say, well, if I'm trying to keep this ratio the same, if I'm trying to make sure that it'll always reduce to 4/3, but I'm not sure what I'm multiplying by, I could multiply by a variable. We don't know what we're multiplying by. When we don't know a number, we use a variable. This is the trickiest part about these problems. You have to know to assign a variable to your ratio numbers. Okay, whatever x ends up being, it's got to be the same thing, so it'll always reduce to that ratio of 4/3. Questions about how or why we're doing this? Okay, so now we can use all this information together to set up an equation. Anybody know what that equation would look like? Beautiful. Length times width, or 4x times 3x, is equal to our area of 108. If you want to put your feet squared on there, you can. You don't have to. To solve this, I need to sort of combine them. I need to go ahead and multiply 4x times 3x. What do I get? Good. 12x squared. Don't forget the squared. Equals 108. To solve it, I would divide by 12. I get x squared equals 9, which means x equals 3 when we square root both sides. Are we all okay with finding x? Are we done? No, they wanted us to find the length and the width. They don't just want x, they want the length and the width. So knowing that x is 3, what do you think the length is? 12. What would my units be? Feet. So we get that by plugging the 3 in for the x. What about my width? 9 feet. Again, we came over here and plugged 3 in for x. And of course, we could check ourselves. If we take 12 times 9, we would get the correct area of 108. Questions, concerns about example 3? Okay, again, the hardest part, other than needing your prior knowledge of area of a rectangle, the hardest part for most students is remembering that you have to assign a variable next to your ratio numbers, because it seems like you kind of pull it out of thin air. Students don't generally like to do that. Ready to move on? Okay. Some of you may have already started it. The measures of the angles of triangle RST are in the extended ratio 2 to 3 to 4. Find the measures of the angles. So, a diagram, again, not totally essential, but it could help. I don't really care what your triangle RST looks like. It could be a right triangle, equilateral triangle, isosceles triangle. It doesn't really matter what it appears to be. What matters is how we label it. So, again, I am not going to label these angles as 2 degrees, 3 degrees, and 4 degrees. What needs to go by them? An x. Because that way, if we were to put them in a ratio with each other, no matter what number x ends up being, it would always reduce down to 2 to 3 to 4. Again, we got to flash back to first semester. What prior knowledge is going to help us in this case? Good. All the angles in a triangle add up to 180 degrees. So while you don't necessarily need your notes from last semester, you still need the knowledge. 2x plus 3x plus 4x equals 180. To solve it, we combine our like terms. How many x's do we have? 9. Well, 3 different x terms, but add them together, we have 9x equals 180. So x equals 20. Questions about how we got there? Are we done? No, the question didn't say find x. It said find the measures of the angles. What are my angles? What's one of them? Angle R is 40 degrees. Make sure you're putting your degree symbol on there. What about angle S? 60 degrees. And angle T, 80 degrees. Okay, now they didn't necessarily say that angle R had to be the one labeled 2. We kind of did it just because they go in order that way. So if you put angle R, measure angle S, measure angle T, that's fine. But if you just wrote those degree measures out, I'm okay with that as well. Questions, concerns, confusion? Need more time on this problem? Warm, fuzzy feelings? Okay, your homework is on that handout. Here it is up on the board as well. Now, if you want to focus your efforts on the homework for the remainder of class, that's fine. or we've got a PSAT 10 practice that I'm about to hand out.
What is the PSA?